Okay, remember that flow chart? I'm going to erase this in a minute, but we take the greatest common factor out first, and then we count the number of terms. So count number of terms. We just recently did two terms, difference of squares. And now what I'm doing is I'm taking you over to the right side of the flowchart, and we're going to look at problems that have four terms. And we say that, and I'm going to go ahead and erase all this, we say that with four terms we factor by grouping. That's the name of the procedure, if you will, factor by grouping. So this is where we're going to concentrate right now here. So I'm going to go ahead and erase this. And so here's what I mean by factor by grouping. So first of all, look at the first problem. It's problem number 13. And there are 1, 2, 3, 4 terms. So when we say factor by grouping, we ask that you group the first two terms, and then you group the second two terms, and from within those groups you take out the greatest common factor. The greatest factor within these groups includes b's, but it's the smallest exponent. All you can get out of these two at most is b to the second power. So I'm going to factor out b to the second power out of this red group. And I'll need a b here so that when I distribute that, I would get b cubed. But then I need a minus 1 here because b squared times a minus 1 would be that minus b squared. Over here, the greatest common factor is a 2. And I've got a plus sign right here. I'm going to factor out a positive 2. And when I do, I'm going to need a b here because 2 times b would be this 2b. And then I'll need a minus 1 right here because 2 times this minus 1 would be that minus 2. What I'd like you to notice is that within these, once I've grouped these and took out the greatest common factors, the binomials that resulted matched exactly the same. What I'm going to do now is I'm going to factor that out of this is essentially called one term separated by a plus sign, and this is called a term separated by that plus sign. I'm going to factor that b minus 1 out, and I'm going to write it down twice. I'm sorry, I said that wrong. It's written down here twice. I'm going to write it down here once. And then this b squared, when I took this b minus 1 out of it, the b squared was left, and then this 2 was left, and I am done. Now what I'm going to do is I'm going to FOIL this so you can see we got what we started with. So this is my answer right here, and then I'm going to explain why this results as well. But let's just check this out. B times b squared, b to the third power, check. B times 2, 2b, check, just not in the same order. A minus 1 times b squared, a minus b squared, check. And a minus 1 times 2 is a minus 2, check. Don't forget, you can always check your work. You can always take your answer, multiply it out, and see if you get what you started with. I want to erase this for just a minute. So hopefully you kept some notes. If not, hit pause. And so I want to go back to this spot right here and explain a little bit more why we write the b minus 1 down twice. And so to do that, I want to do a simple problem off to the side. If we factored 2x plus 8 and took the greatest common factor out of that, we all know that we need a 2 in front and then an x plus 4 here in the binomial, so that this would distribute to be the 2x and this would be the 8. But I want you to know that this 2x plus 8 could intermediary step be written as 2 times x plus 2 times 4. The 8 is 2 times 4. And then we can see the greatest common factor that's in each of those, and we write it down once, and then the x and the plus 4 go in the parentheses, so the b minus 1 comes out, and we write it down once, just like this 2 comes out of each of these, and we write it down once, and then this x and this 4 goes in the binomial, so the b squared and the 2 goes in the binomial. Before I do this next problem, and I'm going to erase this, before I do the next problem, I'd like to take a simple problem that's off of the worksheet that I'm going to assign to you, and it's question number 2, and it reads a squared minus 2a plus ad minus 2d. So I want to get you some practice at this grouping thing before we give you a little bit harder one. So I want to see how many questions I have. Yeah, I just have 4 questions here. So in this first grouping, the greatest common factor is the letter A. That's the best I can get out of this and this. So I'll need an A here and then a minus 2. The greatest common factor between these two is the letter D. So I'm going to factor out the letter D, and therefore I'll need an A here for this right here to be the AD, and this has got to be a minus 2 for this product right here to be a minus 2D. But I peek over here and go, aha, those need to match. And they do, so I'm like real comfortable now. So I write that binomial down once, and then this A and that D go in their own binomial. Don't forget, you could FOIL this to see how you did. So the next one is, you know what, actually I'm going to go over here to number 14. So the only unusual thing about number 14 in comparison to the problems that we've done so far, so I'm going to take you back. Boy, did I forget, I might have forgotten to do this problem. A simple problem. So let's go back here and do it again. So I'm sorry, I'm going to go ahead and do that. No big deal. So I'm going to factor the greatest common factor of an A out. And when I do, I'll need an m plus n here in order to distribute that and get what I started with. The common factor here is a c. And when I factor that c out, I have an n plus m. It doesn't matter. M plus n and m plus n are the same because addition can be done in any order. I'll just choose to write it as m plus n. And then I'll put the a plus c, this a plus c, in the other parentheses. Again, pause and do this one, but a real simple one. So the greatest common factor in this one is the letter A, and I'll need a C here and a D here so that I have AC plus AD right there. The greatest common factor is the letter B. These were much simpler than the first problem I started with. I'll need a C here and a D here. Thank goodness, I'm peeking over here and I want these to match. And so I'll write down the common binomial factor once, and then the A plus B go in the other parentheses. Now what I was getting ready to share with you and I didn't realize is that all of these problems so far have had plus signs between, even this one, have had plus signs between the second and the third terms. But this one right here has a minus sign right there. Be careful. That minus sign belongs to the 2a. So it's minus 2a, but it's a negative 2a. So I'm going to group these two, and then I'm going to group that negative sign in front of that 2. I will not always swipe this from now on, but that is the best way to look at it. So the greatest common factor here is an a to the second power, because you can't go big, you can't go the biggest exponent, you got to go the smallest exponent. So a to the second can come out of that. And then I'll have an a minus 3. The greatest common factor between a 2 and a 6 is a 2. But when there's a minus sign in front of the third term, and also would you notice that this is a minus and this is a plus, unless I factor out a negative 2 right now, I will not be able to cause this to be a negative sign to match this a minus 3, because I really want this to be a minus 3. And the only way for this to be a minus 3 is to factor out a negative 2 so that when I distribute that, I do get this negative 2a, and this negative 2 has to be multiplied by a negative 3 in order to get this positive 6. So a minus sign between the third and the fourth terms, right there, then I'm likely going to factor out a negative greatest common factor so that these will match exactly. And then I'm going to write down that common binomial and then the a squared minus 2 in its own set of parentheses. Don't forget, FOIL it out and check it. Okay, so finally, the last one is very, very challenging. Yes, you could rearrange things. Some people wonder if, you know, maybe because I go to do this and I don't see any greatest common factors here between p's and q's, or 2 and p and q. No greatest common factors. So some people wonder if I should put the p, this 2p here, and throw the q squared over here with the q. So rearrange it and then group these two and group those two. And while they now have a greatest common factor, this one would have a 2p that you can factor out. and this one would have a q, I would factor out a minus q. The binomials don't match. So these don't match. So it's no good. None of this is working. So I can't think of how else to rearrange this. So all of a sudden it's dawning on me. So I'm trying to give you some really, really hard problems here. All of a sudden it's dawning on me that this one is the difference of a perfect square, because the square root of 4 is 2. And these exponents are even. And that binomial can be factored into a 2p in the front of each of these, and then a plus q and at the back of one of them, and a minus q in the back of the other. So this right here got factored into these two binomials. This right here, nothing can be done to it. So when nothing can be done, I'm going to factor out a 1. So I'm going to be very careful if nothing can be done to factor out a 1. And oh my word, look, in this group and in this group, there is a common binomial factor that I can pull out of each of those. So I'm going to pull those out and write the 2p plus q down once, and then this and the 1 have to be put in their own set of grouping symbols like that. And if you distributed this and multiplied this binomial times this trinomial and then multiplied here, 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 you would get what you started with. There will be some terms that will combine and you'll get what you started with. So finally, just one more problem that I'm going to pull. It's off the riddle that I'm going to ask you to do. This is number 10. So similarly to this problem that we just did, this is 4 terms, but when I factor the first 2 and the last 2, or put grouping symbols, here no problem, I can get a 2a out of each of those. And I'll need a b here, so that this will be a 2ab. And I'll need a 7 here. b plus 7, interesting. See this, b plus 7? Nothing can be factored out of that. So when nothing can be factored, put a 1 in front, because 1 times something is still itself. And oh good, now I can bring down this common binomial factor, and the 2a will have a partner with it. It'll have that 1, and you will have your binomial times your binomial, which will FOIL out to be this. Would you now stop this video and do the riddle called How Did Snidely Spellbinder Write a 4-letter word? I'm not going to write this all out. Snidely Spellbinder, write a 4-letter word. The riddle page number is page number 97. Work those problems, factoring by grouping.